All right, guys, but we are going to learn about logs today. So, and how to use that button on your calculator. So a log, just kind of talk through this, what all it's for. Logs are used to solve for exponents, because otherwise we have no way of like getting to them. So we know that 2 squared equals 4, 2 to the third is 8, but 2 to what power equals 6? Right, 2 squared is 4, 2 cubed is 8. I need something in between there. So it's 2 point something, right? So using logarithms is what we can do to actually solve for those exponents. That's how we solve for things like that. Okay? So if you had a question like this is exponential, which is what we were working on yesterday. We can switch back and forth between exponential function and logarithmic functions. The log is what helps us solve them. So for this, you'd have to switch this into this form. And that's the first thing we're going to work on is how to switch between the two forms. So that's what this is saying. You can have, this is read as log base b of y, because that base number changes all the time. Okay? So log base b of y, that's how that is read. So you can switch from this form back into this form. They can go back and forth. And you'll do that a lot when you're solving, trying to figure out what those exponents are. So we're going to get some practice. This is where I think I mentioned to some of you yesterday, loopy swoopy, right? I mentioned that yesterday. That's how I remember how to do these, loopy swoopy, because it works the same way for going from log to exponential and exponential back to logs. It works the same way. So loopy swoopy, very, very technical term. So the first one's done for you. The way this works, you start with that base number. So 5 squared equals 25. You loop and swoop, and it tells you the order that your numbers go in. So 5 squared equals 25. That's how that's written. So this one would be 4 to the third equals 64. 4 to the third. Is that true? Yes. Is 5 squared 25? Does that work? Yeah. So again, it's that loopy swoopy. That's how I always remember the order when I'm switching these back and forth. All right, so the next one is going to be 7 to the negative 2 power equals 1 over 49. 7 to the negative 2 equals 1 over 49. Now let's stop and think for a minute, because I'm going to have you do some of these without a calculator today. Yeah, I know, sorry. We need to know how exponents work. What does a negative exponent do to my number? Some of you are so calculator dependent you struggle with this. What's a negative exponent do? A fraction. It moves it down to the bottom, right? Yeah. So take a look at this one. That's a negative exponent. So that means it pushed the 7 down to the bottom, and then 7 squared is the 49. That's why it's 1 over 49. The negative exponent pushed it down. Because I'm going to ask you things today. I'm going to give you this. I'm going to say, what's log base 7 of 1 over 49? And you're going to have to tell me it's negative 2. So you have to be able to start thinking in terms of those exponents and how those work. All right, so the next one is going to be 32 to the 2/5 power equals 4. So 32 to the 2/5 power equals 4. Now, obviously, that would be a harder one. I'd be really mean to give you one like that to make you do in your head. That one's a lot harder. All right. And the last one would be 36 to the 1/2 power equals 6. 36 to the 1/2 power equals 6. So again, let's kind of stop and think for a minute how, because when you have to do these in your head, you have to be able to kind of think through this. If my numbers are getting smaller, it went from 36 to a 6. I'm not raising it to a regular exponent then, right? What's the 1/2 do? That's a square root. Yeah, so if you're going from a big number, make a note of this, guys. If you're going from a big number, to a smaller number, what has to be happening? You have a root going on. So your exponent is going to be a fraction. So you have to think fraction. So for example, you could write that one. 36 to the 1/2 equals 6 because the square root of 36 is 6. And this will make more sense. We'll do a bunch of them today, so you'll kind of start getting stuck in your head. Okay. And if I have one that I saw it and it's now a fraction, you got to be thinking negative exponents, because negative exponent's what's pushing it down. So if you want to make a note of that one as well. So if you have a number that goes to a fraction, so 1 over your number, something, think negative exponents. There's a great example of it. So today may be the day some of you hit your wall in math. Today's that day where you're like, holy crap, I've never done this before. Like, I've never seen an inkling of this. This is totally new. And you can either quit and just fail this last chapter, or you can push through and we'll get this together. Okay? We're not quitting. It's not an option. Quitting is not an option. So let's work the other direction. So I was doing loopy swoopy, right? Kind of counterclockwise. Same thing. I'm going to do the same way. It's just telling me what order my numbers go in. So if I look at this one, look at the order the numbers are. 5, then the 125, and then the 3. Log base 5, 125 is 3. So if I kind of go the same way, it's always log. So the first number is your base. So base 81. The next number I write down is 3, and that will equal 1 over 4. We have to get good at going back and forth between the two forms. And it's always loopy, swoopy in that same order. It's always that counterclockwise motion. So what's the next one going to be? It's going to be log base 6 of 1 over 36 equals negative 2. All right, next one. So log base 7 of 1 equals 0. Anything to the 0 power equals. Didn't we talk about that yesterday too? Anything to 0 power is 1. All right, and the last one, what's that one going to be? It's going to be log base 9 of 27 equals 3 over 2. Yeah. You can. I'm still moving on, though. It's probably a good choice. All right. Evaluate each log. So this is where your calculator at this point in the game is not real helpful. I'll teach you eventually how it can be helpful, but for now, I need you to understand how logs work, okay? Instead of just, I can type numbers in my calculator. I want you to understand how they work. So log base 2 of 32 is what? And this is what I'm going to ask you to do today on your own. Like, you need to be able to figure this out. So again, you have to be understanding, what's this asking me? If I would flip this into the other form, it's saying 2 to what power equals 32? 2 to what power is 32? Well, 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So I had 5 of them. So that is a 5. All right, so again, the next one, log base 3 of 1. It's not just a simple computation. You got to understand what it's asking. It's asking you 3 to what power equals 1? 3 to what power equals 1? 0. Anything to the 0 power equals 1. Okay, log base 4 of 2. It's asking 4 to what power is 2? 4 to what power is 2? Uh-oh, I went from a bigger number to a smaller number. It's half. Very good. Okay, but again, I want you to kind of recognize when you go from a big number to a small one, then you know that it's a root of some sort, right? That's why your answer is a fraction. All right. This one again is asking you what? 10 to what power equals 1 over 100? What do you notice about your number? Where did it go? It went down to a fraction, which means it has to be negative. And how do you turn 10 into 100? Think about in terms of exponents. You square it. So it is -2. But again, that's kind of those old tricks that we wrote down earlier. If it goes from a big number to a small one, it's got to be a fraction for an answer, which means it's a root. And then if it goes and moves in a fraction, it's going to be negative. All right, let me give you guys a couple minutes. Try these 4 on your own. Doing the exact same thing we just... All right, guys, let's go ahead and talk through these. The question came up from a couple of you of how do I check these in my calculator? My suggestion is the first thing I would do is rewrite it as an exponent in the exponential form. So this is asking you 4 to what power equals 64? So 4 to what power equals 64? So then whatever you think the answer is, you could just plug it in. 4 to whatever you think the answer is and see if you get 64. So 4 to what power is 64? It is 3. Okay, let's do this one down here next. So again, it's asking you 1/5 to what power, 1/5 to what power equals 125? Well, I start with a fraction, and then I don't have one. How do you move the number from the bottom and move it up? It's still a negative exponent, right? Negative exponents are just moving them. So that way I know that this is going to be negative. And then how do you turn a 5 into a 125? Good, cubed. So it's going to be -3. So negative exponents kind of work both ways, right? If I went from a fraction to not a fraction, the negative is what's moving it. Or I could go the other way with that. And then once I know it's negative, because that's going to flip it back, and then 5 to what power is 125? Well, 5 times 5 times 5. So 3 5s. We've got to think exponents. That's the trickiest part. Up here, we have 5 to what power equals 0.2. The hardest thing about this one is when it's written as a decimal. I hate decimals. What's 2.2 as a fraction? How would you read that number? Not 0.2, but it would be 2/10. If you say 2/10, that would simplify to 1/5. Well, how do I turn a 5 into a 1/5? How do I move it? A negative, yeah. So the negatives can take my 5 and move it to the bottom, and I want it to stay a 5. So it'd be -1. Again, if you're checking, grab your calculator. 5 to the -1 powers, you should get 0.2 or 2/10. All right, and then the last one, 36 to what power is 6? 36 to what power is 6? I went from big to small, which means it has to be a fraction. So fractions are like roots. Square root, cubed root, fourth root. What root is that? What root of 36 is 6? The square root, which would be 1/2. That's a square root. It's going to take a little while. I know. It's going to take some time to get your brain to kind of circle around to all this. Can my calculator help me? You got a button that says log on it, right? What happens when you hit the log button? Just grab your calculator. Okay, I hit log, what comes up? It says log, does it open a parenthesis for you? Okay, so how would you type in log base 36 of 6? It's not so pretty, is it? And there's different things you could do in the graphing ones, but for the most part, what I need you to understand, when you hit log, it's doing a common log. Okay, common log is a base of 10. So if there is no base written there, we are assuming it's a 10. So great. Math has unspoken ones, it's got unspoken zeros, it's got unspoken twos and square roots. Now it has an unspoken 10. Mathematicians are lazy. We don't write as many things as we don't have to write. So log base 10 can be written as just a log. If you don't see a base number, it's implied that it's 10. Okay, so if I see log of 10, it really means log base 10 of 10, which is 10 to what power equals 10? 1. So in your calculator right now, go ahead and hit log and then type in 10. 1. Because your calculator is putting in a base of 10. That's the common, that's just by default what it goes to. So 10 to what power equals 10? It is a 1. So what about log of 100? Can I use my calculator? I can, because that's a base 10. Or if there is no base number, we're assuming it's base 10, and then you can use your calculator. So it's 2. Why is it 2? Tell me what that means. Because it's asking you 10 to what power equals 100? 10 squared is 100. All right, log of 1 over 100. It's negative 2. Again, kind of thinking through this, if that's a 10, so 10 to what power equals 1 over 100? Well, I'd have to move it to the bottom. Moving it means it's negative. And 10 squared is 100, so it'd be negative 2. Log of 1? 0. Good. All right, because again, 10 to what power equals 1? Well, 10 to the 0 power is 1. Log of 0.1? Negative 1, because again, that's a 10. 10 to what power equals 0.1? Well, that's 1/10. To move the 10 to the bottom, you know it's negative, and 10 to the first is still 10. But we have to start switching our brain to exponent thoughts, not just multiplying and dividing. All right, how about that one? Log of 1/3 is what? Again, since my base is not given, it's assumed it's a 10, then I can use my calculator. So 10 to what power is 1/3? Is it pretty? Yeah, I mean, I didn't write all the digits up there, but like, why is it not pretty? Stop and think what it's asking you. It's asking you 10 to what power equals 1/3? Well, the number moved to the bottom, so it moved, so I know it's negative. Can I nicely turn a 10 into a 3? No, I can't. That is why it is such an ugly number. Okay, what about the next one? Log of 2.5? Ten to what power is 2.5? Yeah, again, it's not pretty. Uh-oh. Why? And this next one, take a look at what it's asking. It's asking you 10 to what power is negative 2? Can you raise a positive number to an exponent to turn it negative? I can't. So on this one, that is why your calculator Why? That's why it gives you the error, domain error, some kind of message on it. Because you can't. You got what? No real answer? Yeah, because it's not real. Right? That's why we couldn't do square roots of negative numbers. We just can't do it. So, will I give you things like this? No. But I just need you to understand why. Okay? Because it's asking you to turn a positive number into a negative by raising it to an exponent, which is not possible. All right, so what we're going to do next is we're going to get some practice. We're going to play war. You guys remember how to play war, right? No? Decks of cards. Each person gets half the deck. Flip a card up. Whoever has the highest number gets both cards. Remember? War? War? Yeah, you remember war now? War. Yeah, the card game. So what I need from you guys is to find a partner, and then you'll probably need a calculator so you can kind of check your work here, and then like scrap paper, or you can use the dry erase boards and stuff. Because I'm not just giving you a regular deck of cards. That has nothing to do with what we're doing right now. I'm giving you cards that have logs on them. So we can get some practice working through the logs to figure out what the answers are for them. Okay? So find a partner and either grab a scrap paper or the dry erase boards.